Okay, here we are. Lesson 10.4, perimeters, area of similar figures. It is the last lesson that we're doing in chapter 10. Our learning target is I can find the perimeters and areas of similar figures. And we're working here with theorem 10.7 first. It says perimeters, areas of similar figures. If the similarity ratio of the two similar figures is A to B, then, and we got to figure out the then. We're going to figure out what the ratio of the perimeters is and what the ratio of the areas is. And so we're going to use a couple of rectangles that are similar. Okay, and we'll say that this rectangle is, let's say, 8 inches, and this one is 20 inches here, and this one is 6 inches. Doesn't look quite like 6, but we'll go with 6, and this one is 15 inches. Okay, pictures are not necessarily drawn to scale. All right, our similarity ratio which is our scale factor. Basically, I'm just going smaller to larger. So I'm going to do 6 to 8, simplifies to 3/4. I can check it here, 15 to 20, simplifies to 3/4. Okay, next thing I'm going to look at is our perimeters. Okay, so the small one, I'm going 2 times 6 plus 15. 2 times 21 is 42. And I'm going to do 2 times 8 plus 20. So 28 times 2 gives us 56. And then I'm going to write a ratio here for 42 over 56. And when I simplify that, that simplifies down to 3/4. All right, for our areas, 6 times 5 for the smaller one. This would be 6 times 15, that's 90. And then for the larger one, I do 8 times 20, 160. And when I simplify this ratio, 90 to 160, it gives me 9 over 16. Okay, now here's what you should notice. Notice that these two are the same, 3/4 and 3/4. And it should be, okay? Similarity is based on the lengths of the sides. Perimeter is just the lengths of the sides added together. Okay, so it's still being measured in terms of length. Whereas area now is length times length. So we've squared things. So with that in mind, look at how this number and this number are compared. And the 4 and the 16, or the 3/4 compared to the 9/16. This is nothing more than 3 squared over 4 squared, or 3/4 squared. Okay, so basically our scale factor is the same scale factor for perimeter, but when we go to finding a scale factor for area, we take that one for similarity or perimeter, square it. Okay, which tells us right here, if the similarity ratio of the two similar figures is A over B, then the ratio of the perimeters is A over B. If that's true, the similarity ratio is A over B, the ratio of the areas is A squared over B squared, or A over B squared. Okay, so let's practice that on this one. It says the trapezoids below are similar. Find the ratio, smaller to larger, of the perimeters. Okay, I can't figure out the perimeters. I don't know enough about it. All I know is that dimension. All I know is that dimension, but I know they're similar. So if I could find a scale factor from here to here, I could use that same one to answer these two questions. All right, so I'm going to take and do this. That scale factor is going to be 6, and I'm doing smaller to larger, so 6 to 9 simplifies to 2/3. Okay, and that also becomes a ratio for the perimeters. Okay, now I want to try to find the ratio of the areas, and I know all I got to do is square it, right? So for area, it's going to be 2/3, but the 2 is squared and the 3 is squared, so 4/9. Okay, next. I have two similar polygons that have corresponding sides that are the ratio 5 to 7. Find the ratio of the perimeters. Well, the ratio 5 to 7 for the similarity, ratio of the perimeters, 5 to 7. Ratio of their areas, 5 to 7 squared, so 25 to 49. Okay, the next one. Ratio of the lengths of the corresponding sides of two regular octagons is 8 to 3. The area of the larger octagon is 320 square feet. Okay, so this was sides, or similarity ratio. This is talking about area. That's the larger one. I want to find the area of the smaller one. Well, if my similarity ratio, or my perimeter ratio, is 8 to 3, my area ratio is going to be 8 squared over 3 squared, or 64 over 9. So now I'm going to just do a proportion. 64 over 9. And this area is the area of the larger one, so I'll put the 320 in the same place, corresponds with 64. And this is going to be x. And x will give me the area of the smaller octagon. Now I just do cross product. 64 times x equals 9 times 320. Divide this by 64, and that by 64, and it gives me x equals 45 square feet. And my next one, Benita plants the same crop in two rectangular fields, each with side lengths in a ratio of 2 to 3. So I've got a ratio here of 2 to 3. It also says each dimension of the larger field is 3.5 times the dimension of the smaller field. Larger field is 3.5 times the dimension of the smaller field. Okay, so here's what I got to think about. I got basically two ratios listed here. I got to think about this. Okay, it says here the side lengths in the two fields are both in this ratio, where basically if the width is 2, the length is 3, or 2x to 3x. Well, that's not my similarity ratio between the two shapes. Okay, that's what this 3.5 is. If this is 2, well, the next one is going to be 3.5 times that on the bigger one. So larger to smaller, I'm looking at 3.5 to 1. Well, 3.5 to 1 is the same as 3.5. I'm going to rewrite that as an improper fraction. So 2 times 3 is 6, times 1 gives me 7 halves. That's my ratio. That's my similarity ratio. That's my scale factor. So if that's 7 over 2, for area it's going to be 7 squared, or 2 squared, or 49 over 4. Okay? And so now I'm going to set up a proportion. 49 over 4. Now, it also, here's the other thing. I didn't even get to this part yet. Seeding the smaller field costs $8. That's based on area. How much money does the seeding for the larger field cost? Well, $8 was a smaller field. That corresponds with the 4. So I'll put $8 down here. Put an X up here. All right, and now I'm going to do cross products. So I have 4x equals 49 times 8. And divide this by 4 and this by 4. And I get x equals $98. Okay, now, if you're not convinced that we did everything right here, here's another thought. 3.5 times the dimension. Okay? 3.5 times each dimension to get the larger dimensions, which means the area is going to be 3.5 times squared times that original area. So if I do that $8 times 3.5 squared, guess what I get? I get 98. It's the same thing I got there. Okay, so that works out nicely. All right, the last one. You have the area of two similar pentagons of 32 inches squared, 72 inches squared. What is their similarity ratios? So I'm kind of working this one backwards, right? My area, 32 to 72. And I find that normally that what helps here is to simplify that. So I divide 8 out of both of those, and I get 4/9. And now I know I could take the square root of that. So my similarity ratio is going to be the square root of 4/9, which is nothing more than 2 over 3. Okay, which is a similarity ratio. and perimeter ratio. All right, and that's it. A little bit quicker lesson today. The next day, not today, but the next time we have class, we're going to be doing a review of the entire chapter and taking the chapter test for chapter 10. All right, have a great day.